All right, the next type of endangered habitat are grasslands, and I mentioned this before, but most grasslands are have been converted to agriculture. This is mostly because grasslands have very highly fertile soils. A lot of prairie plants put a lot of their growth underground in roots. And as those roots die and decompose, it really makes this or high organic matter soil with a lot of nutrients in it. So between 1800 and 1950, 98% of North America's tallgrass prairie and oak savanna was converted to agriculture. And so you can see here is the former distribution of tallgrass prairie. The largest extent of tallgrass prairie remaining is a Nature Conservancy property right here in Oklahoma. But almost all of it is gone. And the places where lots and lots of corn are grown, it's almost completely gone. So all of this in Illinois and Iowa and northern Missouri, almost all of that is now corn and soybean fields. What remains is highly fragmented. So that means that it's in little tiny pieces and there aren't very many large extents of prairie remaining. So this shows Illinois, and what you can see here, it's a little bit hard to tell. This kind of peachy color in Illinois from the early 1800s, that's all prairie or grassland. And you can see there's not any yellow hardly on this map, and that was agriculture. If you look over here, this is present day. The yellow is agriculture, and the pink is like developed urban suburban land. So you can see that that peach color is almost non-existent. Like I'm not sure I can really find much. There might be some patches down here in the southern end of Illinois. And the forest has been degraded a lot too and turned into agricultural fields. So there's almost no prairie left in Illinois. The next category of endangered habitats are aquatic habitats, which includes wetlands. They are really important for wildlife. There are a lot of waterfowl, amphibians, fish, obviously, need aquatic habitats and wetlands. Wetlands are extremely important for flood control. They soak up water really well, and they're also really good at filtering water. So purifying water that can be used for drinking water. But also some places they utilize wetlands to deal with wastewater. And so as a way to make our wastewater clean again, they run it through these wetlands and they pull out all the nutrients and purify that water so it can go back into rivers and lakes. Historically, wetlands were not thought of very highly, and they're still probably not thought of very highly in many areas. They seem to be a nuisance. People think of them as only places where mosquitoes breed. So they've been filled in or drained so that they can be used for what people call productive land. So you can put parking lots and buildings. A lot of places that historically had wetlands have been tiled and had ditches put in to drain so that agriculture can be done on that land. So San Francisco Bay used to have lots of wetlands, and this is also another map that the colors were not chosen very well. So this very kind of light, off-white, creamy color, which I'm outlining here with my pointer, are the wetlands from San Francisco Bay from 1848. So they can see they're all through here. And the green are just what is remaining today. So, and you can see that there's a margin around the South San Francisco Bay that used to historically be wetlands as well. And so San Francisco Bay has lost almost all of its marshes due to development, but also sedimentation. And so sedimentation is just filling in of wetlands as erosion from other areas carry basically dirt and sand downriver, and it fills in wetlands so that they no longer hold water. This shows loss of wetlands across the United States. Each parcel is a hydrologic unit, and you can see that the red areas have high levels of wetland loss. Again, areas where there's been a lot of agricultural development. So we saw Illinois had lost a lot of grassland. It's also lost tons of wetlands. The yellow has moderate level of wetland loss, and the green is low level. So almost nowhere in the continental United States has a low level of wetland loss. We see a little bit in Montana and a little bit in Maine, and pretty much nowhere else has a low level of wetland loss. Wetlands can also be, and aquatic habitats, altered dramatically by the installation of dams. And so this shows a stream or river, and before a dam is put in, it tends to have lots of habitat heterogeneity on the bottom. If you'll remember that word, means different kinds of habitats available. So there's places for fish to spawn. Some of them need certain rock structures to lay their eggs on. They have fast-flowing water. They also transport sediments and nutrients downstream. They allow the passage of fish up and downstream. So some fish require unobstructed rivers and streams in order to do their migration. So salmon are one, freshwater eels are another one that need to be able to travel up and downstream. And then they tend to have cool temperatures in normal free-flowing streams and rivers. When a dam is installed, it creates basically a small lake called a reservoir upstream of the dam, and it changes it from a fast-flowing cold water habitat to a slow-flowing warm water habitat. So basically a lake. It fills in with sediment. So as the water slows down, all the sediment and nutrients that were in the water, as the water slows down, those fall out. If the water's moving fast enough, it'll keep pulling dirt and sand through the water as it flows. But if it slows down, it's not moving fast enough to keep carrying that, and that falls out. And so dams actually have a lifespan, usually because they fill up with sediment eventually. So either the lake reservoir will need to be dredged at some point and have the sediment pulled out, which can be detrimental to organisms that have been living there and dealing with this different type of environment. But the water is a lot warmer, and it also increases the water temperature downstream. And as water temperature increases, we get a decrease in oxygen. And so you get a totally different habitat here, and dams change the habitat dramatically from what they were before the dam was installed. As I mentioned, dams, the reservoirs eventually will fill up with sediment, and this is called sedimentation. And so a lot of dams are used for electric generation, so that dredging will often happen if the sediment is too high for the turbines to turn anymore for generation of electricity. This shows Glen Canyon Dam, and it looks at the thickness of sediment. And so the sediment accumulates closer to the dam to start, and then it'll fill up in other parts, even tributaries you can see. And so you can see there's low sediment up here, but here there's a lot of sediment. And so a lot of these reservoirs are useless within 100 years unless they're dredged out. Also, dams are very good for water storage. Those reservoirs hold a lot of water, but as the sediment fills up, it holds less and less water through time.